So this is question number 4. Since I don't have the quiz with me, I wrote the question over here. The question is, a boat travels at 250 miles per hour due west. If there is a 25 miles per hour current at north 35 degrees west, find the actual speed and direction of the boat. Round your answers to the nearest tenth. So over here, I drew the diagram. Since the boat travels at 250 miles due west, it's represented by this vector over here. And then the current is 25 miles per hour north 35 degrees west. This is represented by this vector over here. It's the magnitude is 25 miles per hour, and then it's going to it's north 35 degrees west. So this angle here is 35 degrees. And the question asks to find the actual speed and direction of the boat. So this vector over here is going to be the actual speed and the direction of the boat, because when you add these two vectors together, this will be the resultant. So because you want the boat to travel this way, so that means you have to add these two vectors together. And so over here I wrote that this is the vector of the current plus the vector of the boat. When you add these two vectors, you're gonna get the resultant, which is over here. So since we already know the resultant and the vector of the current, that means to find B and to rearrange this equation, I have the vector of the boat is equal to the resultant minus the current. So my approach to this question was to use vector components. To write R, it's pretty simple because it's just negative 25 comma 0. So to find the vector components for the current, I did cosine 125 times 25, and then the y component is sine 125 times 25. The reason why it is 125 is because this angle over here is 90, so 90 plus 35 is 125. So when I did the math, I have the x component is negative 14.3, and then the y component is 20.5. And so over here, we know that if you want to subtract two vectors, it's basically kind of like how you would add two vectors, except you have to multiply the second vector by -1. So this is what's represented over here. And then I added the x components and the y components. The x components are negative 250 and then negative 14.3, but since I have to reverse the sign of the second vector, it's going to be negative 250 plus 14.3, and then I did the same thing for the y component. And so for the component, I have that the actual speed of the boat is going to be negative 235.7, and then the y component is negative 20.5. So since I have the components of the vector, it will be very easy to find the magnitude because it's just to use the distance formula. And this is what I did over here. And I have that the magnitude of the actual speed of the boat is going to be 235.6 miles per hour, because the question says to round the answer to the nearest tenth. And to find the direction, it will also be very simple because I already have this vector written in its component form. So I drew the diagram over here. We know that it's negative 235.7, so it's gonna go this way. And then it's also coming down 20.5, so that's over here. So to find the direction, I have to find this angle over here. I use tan theta. So tan theta is equal to negative 20.5 because it's going down, and then 235.7 it's going to be negative because it's going to the left. So for the angle, I have that it's around 4.97, and since I have to round all my answers to the nearest tenth, it's going to be 5.0. And then to find the direction is pretty simple too, because since I already have this diagram, you know that this is west and then this is south. So it's just gonna be west 5 degrees and then south. So this is question number 4.